This is the video for Unit 8, Lesson 4, three variable systems. So the goal for this is going to be using what we know about elimination and substitution to solve systems that have three variables and three equations. What we're going to see is that we can have a couple of different scenarios that happen very similar to when we just have two equations. So really when we think of three variables, we're actually thinking of three dimensions. But for our purposes, we're going to see a lot of the same things that play out. So you're either going to have one solution, infinitely many solutions, or no solution. We kind of start introducing the idea of x, y, and we also kind of introduce this idea of z, right? If we write it as a coordinate point, it would be written as x, y, z. So nothing really too much of a stretch. We're just adding that third variable there. But we're going to walk through just a few examples of how you would eventually see it with three variables. So it's just kind of like an introduction to three variables. So the first type we might see is solving with substitution. So notice we have x, y, and z in this problem. We have three equations and three variables. So our first step we're always going to have is we're going to choose one equation to solve for one of its variables, because again, we're using substitution. And this one works out kind of nice. Out of the three equations, I'm going to call this, just for the sake of talking about these equations, I'm going to call this one equation 1, equation 2, and equation 3. We can see equation number 1 has a variable already by itself. It has x equals. So I'm going to write x equals 2y. And this is my equation I'm essentially going to use to substitute. What we're going to do now is take this equation and substitute it into equation 2. But we're also going to substitute it into equation 3, right? So we're still doing that substitution step. So let's say I call this one equation 2. This one, I'm going to put in 2y in for x. And then I'm going to do the same thing with equation number 3. But I'm going to substitute in my 2y in for x. If I go ahead and solve it out, I get negative 8y for the second one, plus y minus 2z equals 1. I'm going to combine like terms. All right, and that's as far as I can go with that, this new equation I just created. When we substitute into equation 3, I have 4y plus 2y minus z equals 10. 6y minus z equals 10. And now this is as far as I can go with that third equation. And now I'm going to take these two brand new equations that I made after I substituted, and I'm going to rewrite them. And what we essentially just did is create a problem that we're now used to solving. Right? So like I can see now, this is just an elimination problem just with z's and y's now. So I see, like, for example, this is negative 2z. This is a negative 1z. Maybe I'll use elimination. And I can multiply the bottom by negative 2 to get a pair of opposites, but lots of ways to do the same problem. So the first one would stay the same. The second one, when I distribute, I would get negative 12y plus 2z equals negative 20. We're going to go ahead and add these straight down. The z's go away. And then when I divide, I'm going to get y to be negative 1, or I'm sorry, positive 1. So now when I solve this out, I can go and substitute the values in to figure it all out still. So I have my y. I'm going to put y back into any equation I like. Maybe I'll do this one down here. So 6y minus z equals 10. I'm going to replace that y with a 1. Subtract. Divide. I get z to be negative 1. Or actually, I'm sorry, negative 4. And then from here now I'm going to take these two and try to solve for x. So x, if I go back to my original problem, this one's probably the easiest one to solve for x. I had x is equal to 2y. So I just found y is 1. So 2 times 1 is 2. And that would be my answer. So if I write it as a coordinate point, I would write 2, 1, negative 4, because it goes in the form of x, y, z. And that would be it. The U try is very similar. So we'll go to our last example is elimination. So it's the same concept. I'm going to start by, I'm going to number these equations just to make them easier to talk about. You don't necessarily have to do that, but I have equation 1, 2, and 3. And what we're going to do is we're going to just pair up to see if we have any opposites that are easy to work with. And this one actually worked out nice. I actually have the y's have a lot in common, right? So I'm going to pair up two equations at a time. And I gave you a hint that you're going to solve for y here. So I'm going to first pair up equation 1 and equation 2. So I'm going to use, this one's going to be equation 1 and equation 2. So if I look at equation 1, I have x minus 3y plus 3z equals negative 4. I have 2x plus 3y minus z equals 15. They're already a pair of opposites, so I'm going to add them straight down. I have 3x plus 2z is going to equal 11, and that's as far as I can go with that one. I'm now going to go to pair up another pair, and I actually have a second pair of opposites if I use equation 2 and 3. So I'm going to line them up. And if I add them straight down, we'll get 6x minus 2z is equal to 34. That's as far as we can go with that equation. And now I'm going to use my two new equations to write my problem. So maybe I call this like 4 and 5, but you don't have to number them. So I'm going to take my two new equations and solve it just like a regular system. So I have 3x plus 2z is 11. I have 6x minus 2z is 34. I already have a pair of opposites in there. So I'm going to do the same thing. So I head it straight down. 9x is equal to 45. And then if I divide, I'm going to get 5 for x. I'm going to substitute it back into either of the two new equations. So maybe I'll do the top one. So 3 times 5 plus 2z is 11. 15 plus 2z is 11. And solve. So z is negative 2. All right, so we got x and z. And now we're going to take both of those and put them into one of the original equations. It doesn't matter which one you use. I might use, let's say, the top one. So if I rewrite it, I have x minus 3y plus 3z is negative 4. And then just take your values you just found and put them in. So we have here 5 minus 3y plus 3 times negative 2 is negative 4. So once we substitute in, we'll get 5 minus 3y minus 6 equals negative 4. That'll be negative 1 minus 3y equals negative 4. And then we'll solve it out. So we'll add 1 and divide. So y would be equal to 1. So our final answer would be 5 comma 1 comma negative 2. And that would be it. If you have any questions, you could ask in class, sign up for T-Volt time, or go to the center.